thanks to Anthony who's joining us today, and he will be presenting. So yeah, that's good. Yeah, Anthony actually will go first today. Just a reminder, Anthony will go first, and then we'll have James going second, and Amaya go third. I think I can wait maybe one more minute just for people to show up. Then we can start. And yeah, in the meantime, I would remind you that please feel free to ask your questions in the chat. While we have presentations, we have again three presentations, 5 minutes each. Again, I wouldn't be too much worried about the time since we have a whole hour for only three papers. And yeah, so yeah, I think we can start. If you guys are all here ready. So hello everyone. Welcome to this refactoring session at ICSI. Today we'll be presenting three papers again. So we have Anthony Peroma presenting the first paper, which is a journal first paper. Then we have James presenting an industry paper. And then we have Amaya presenting a technical paper, 3 minutes or 5 minutes each. And then we will have discussions afterwards. Feel free to share as the presenters are presenting, feel free to ask your questions in the chat. And then I will ask all the presenters to open their cams so that you would know them, and then we can have a discussion. I will also feel free to also interact with us. Feel free to be live and open your cam and open your microphone, and feel free to discuss with the authors directly. So with that being said, we can start with our first presentation. So Anthony, please go ahead.
Sure, thanks. So, hi everyone, my name is Anthony, and on behalf of my co-authors, Stephen, Iman, Christian, and surprise, Mohammed as well, and Ali, I will be presenting our journal first paper entitled "How Do I Refactor This? An Empirical Study on Refactoring Trends and Topics in Stack Overflow." And like I mentioned, this is a journal first paper, and it has been published in the Empirical Software Engineering Journal. And I tried my much as best to try to compress it into 5 minutes, but I also have a longer presentation available, and that longer presentation is linked on the conference website as well. So if this is too short, you can always have a look at the longer presentation as well. All right, so as most of you know, most of the prior work in the area of refactoring has been on empirical studies on open source systems. And however, little is known about the adoption of refactoring activities in practice. For instance, is refactoring just limited to fixing code smells? Because we all know industry projects are very complex, right? And these complex projects require very complicated solution. So the question is, can developers utilize the concepts that they learn in the classroom and also what they read in textbooks? Can they utilize those concepts in real world systems? So, as a research community, we need to know what gaps exist between refactoring as research and its adoption in practice. And hence, to do this, we need to extract common refactoring intents that align with the real-world activities that developers perform. So therefore, in this study, we mined refactoring posts on Stack Overflow to examine the real-world trends and challenges developers face in refactoring their systems. Our work helps researchers and also tool vendors to better support developers in implementing and maintaining software systems. So we have three research questions. The first examines the growth of refactoring discussions on Stack Overflow and the technology landscape involved with developers refactoring their code. The second research question utilizes natural language processing techniques such as bigrams and topic modeling to basically present a more granular view of the challenging areas of refactoring that developers encounter or they require assistance with. And the final research question examines the refactoring topics that are popular among developers and also the topics that are difficult to answer. With regards to contribution, a tangible outcome from this study is a discussion on how the community can utilize our findings to evolve the field, and also a publicly available data set which can be utilized in future studies in this area. And details on how to obtain this data set are available in the paper. All right, so basically to answer our research questions, we utilize the Stack SO torrent data set that's currently hosted on Google BigQuery. And from this data set, we extract the data that is pertinent to our study. So, post, tags, answers, and so on and so forth. So roughly we extracted around 9,000 questions and around 20,000 answers. So next, to answer our research questions, we followed a mixed methods approach where we collected and analyzed both quantitative and qualitative data. So our quantitative approach utilized well-established statistical measures and custom code to report on trends and patterns. On the other hand, our qualitative approach relied on a manual examination of the post. So again, if more details about our methodology is available in our paper, so please go ahead and do read the paper to figure out exactly more details about how we conducted our experiments. So moving on, our RQ1 findings show that Stack Overflow is a popular venue for developers to seek assistance with refactoring problems, and we noticed that the number of questions and accepted answers have been increasing every year. And most of the questions actually receive a response within a short period of time, roughly around 15 minutes since posting a question, that question will receive an answer. And we also observe a rise in questions around dynamically typed languages like JavaScript and Python. Our RQ2 findings highlight 5 topics developers seek assistance with when it comes to refactoring. And these topics are code optimization, tools and IDEs, architecture and design patterns, unit testing, and database. And finally, in RQ3, we observe questions on tools and IDEs are not only the most popular, but they also are kind of challenging when it comes to, providing answers. So they are very popular in terms of the number of view counts, number of people accessing these questions, but they're also tough when it comes to providing answers. And on the flip side, the least challenging questions are the questions regarding code optimizations. Like, for example, how do I, reduce this long method, or how do I convert, this lengthy switch case to something more simple and things like that. So those questions are much more easier to answer. So the findings we present in our study can be utilized by multiple groups of individuals to improve code maintenance activities. For example, when it comes to the researchers and academia, our research can be used by the research community and the academic community to help in revamping course curriculum to reflect more real-world settings such as dynamic language refactoring and also refactoring non-source code artifacts. The developer community should look at extending coding standards, especially around naming to other project artifacts, right? We all know naming is important for variables, methods, and all, but how about naming for database tables, content within XML files, SQL scripts, and so on. So naming should be extended more past source code. And finally, the IDE and tool vendors can invest in improving developer productivity by automatically synchronizing refactorings between project artifacts. So for what I mean is, like, if you were to go and change something in the refactor code in the model, the tool or IDE should propagate those changes to the data layer, to the unit tests, and so on and so forth. And with that, I've come to the end of my presentation. Thank you very much.
Thank you, Anthony, for the presentation. Again, reminder for everyone, please share your questions in the chat or keep them until the end of the session. So this, with all the 3 talks. And with that being said, now, James, you can start.
Okay, thank you, everyone. So I'm James Ivers from the Software Engineering Institute, and I'm going to give you a quick overview of a survey we conducted to understand the state of large-scale refactoring in industry. For those who aren't familiar, our team at the SEI, EPEC and myself being good representatives, we tend to focus on architecture scale challenges that organizations have. And anecdotally, over the years, we've worked with any number of industry and government organizations that face what seems to be a recurring challenge. That is, when we have successful systems, we tend to want to do more and more with them. And some of these changes require us to first restructure the code in order to support the kinds of features we want to introduce, the technologies we want to integrate, and so forth. And organizations tend to have a lot of difficulty. These are expensive propositions that oftentimes management shies away from. So no surprise to this crowd, Murphy, Hill, and Black introduced a useful metaphor to differentiate some kinds of refactoring. Flawless refactoring being sort of the continual, lightweight sort of things that developers can do organically as part of development. And there's lots of evidence that developers do this. We're looking more at the root canal refactoring side of things. These are sort of interventions to come through and repair something significant. Again, oftentimes from our experience, it's to enable some future change to broaden the capability of a valued system. But when we think about these from an effort perspective, but the intuition seems to be that floss refactoring is something developers can do minutes and hours of effort. It's not terribly visible to management. Root canal refactoring, on the other hand, tends to involve, especially at the larger scale, groups of developers working together to accomplish some larger architecture scale goal. These are efforts that really can't escape management intention. Instead, they need management buy-in, extended communication, and coordination among different teams. It gets a lot more challenging at this scale. And so this is really what we want to understand better, is that this right end of the scale, efforts that take often teams, months to years of effort, and go beyond simple things that we can do quickly without a whole lot of outside coordination. So we wanted to understand whether our anecdotal evidence matched a broader study. And so we sent out a survey to industry practitioners. We got more than 100 responses, I think around 90% of whom came from experienced engineers with more than a decade of experience. So we asked questions in three main categories. The first in which we focused on occasions in which participants had actually performed large-scale refactoring. So we asked of them questions about what kinds of tools that they used, what activities were more or less challenging, took more or less time, made more or less use of tools, and really tried to get an understanding of how practitioners are doing this today. In the second category, we caught essentially the unfortunate alternative. Occasions in which teams had wanted to perform large-scale refactoring, but for some reason had not. And here we were more interested in what were the reasons why they didn't do that kind of refactoring, and what were some of the consequences that they observed after having not done what they had intended to do. And for the last category, we just opened the door, and with an open response question, we asked what kinds of tools would have helped your efforts when you had been doing large-scale refactoring. And so there's a lot more than I can go through in all of this, but a couple of nuggets that we think are particularly interesting. One that's not on the slide is that this is a relatively common thing from the respondents' experiences. The majority of respondents had done large-scale refactoring multiple times in their career. And on the systems on which they reported doing large-scale refactoring, the majority had gone through this multiple times in the life of the system. Now, the plot here on the left is one of the interesting things, is we asked participants to estimate how much project time, not personal time, was spent in these large-scale refactoring efforts. The distribution is quite large. The mean comes out to about 1,500 days of effort, which is quite considerable. But when we look at that benchmark we set of months to years of effort, more than 85% of the responses that we got fit that category. So it's not uncommon for this to be a large, significant effort that takes a whole lot out of teams to do. On the right is a quick slice of a coding exercise we did from an open response questions where we asked participants to share what specific tools they had used, or at least categories of tools. And there are a few things that kind of stand out. General purpose tools like IDEs and testing tools are widely used, just as they would for any other kind of development effort. Refactoring tools, low on the scale. Very few respondents actually called that out as something that was helping them with their efforts. And that points to an opportunity for improvement for this kind of exercise. Also, what's interesting is if you look towards the top here, this other and manual efforts, we got a lot of responses that spoke to developing custom scripts to solve their own problems, or just applying brute force efforts, or very low level primitives like grep, sed, awk, and these sorts of things. So this paints a picture, if you will, of efforts that are really expensive, and that have plenty of room for better tool support. Now, there's not a lot of time to go into gory details, but the study artifacts are available for those who want to take a look at the raw responses and the coding. And also, I will point out before we adjourn that this is an active area of research interest at the SEI. We're also starting to work on some tooling to help with some of these challenges. And we are hiring. If there are other researchers out there who are interested in this topic, we would love to have a conversation. Thank you.
Thank you, James. A very interesting talk. Probably we're going to have a good discussion soon. So I'm looking forward to that discussion once we are done with our third talk with Amaya.
Hello everyone. Can you hear an echo? Yes or no?
You're good.
Okay. I hear an echo. Okay, hello everyone. I'm Amya Ketkar. I currently work at the Programming Systems Group at Uber. And today I'll be presenting our work inferring and applying type changes, which I did as a grad student at Oregon State with my PhD, during my PhD with Danny. As developers, we keep evolving our code to make it more understandable, efficient, or just to adapt to a new requirement. For example, since Java deprecated some of its classes from the datetime library, I had to perform a type change from simple date format to datetime formatter. Basically, a type change is a transformation where you change the type of the local variable, a parameter, a field, or a method return type, and then you update all the other parts of the program in order to propagate the constraints of the new type. For instance, here I updated the right-hand side of the assignment from object creation expression to a static method call. And I also had to perform another type change from date to local date like this. So there are several reasons to perform type changes. A lot of motivations like library migrations, improving performance, introducing abstraction, introducing concurrency, improving the maintainability of the code, and many more reasons. In ICSI 2019, we proposed T2R, a tool that performs type migrations in ultra large scale code bases by generating a graph model of the type dependencies across the program elements. To use this tool, the user basically has to encode syntactic transformations required to perform the desired type change, and our tool will perform these type changes across the entire code base. For the purpose of creating these, so basically the problem with this tool is that, or like the Achilles heel of this technique is that the user has to manually encode these transformation specifications. Now, when you're manually encoding these specifications, you may want to know more about the types that are involved in the type change. So you may ask like a code developer, look up documentation, Stack Overflow, so on, and then handcraft these. Or else you could also learn from the uh, learn from the type changes that are performed by other developers previously in their code bases by mining GitHub. So rather in our empirical study, understanding type changes, we observed that 3% of the type changes account for like 46% of the total instances of type changes that we observed. So to overcome this problem of manually encoding specifications, we propose TC Infer. As input, it accepts the version history of Java projects. It will analyze each commit in the history to look for type changes and generate the rules for all the type changes that it found in the commit history. So let's say for simplicity, our the TC infer basically reports a table of type changes that it found in the corpus. Here you can see that a row in this table is basically the before and after type. To each row, let's say there is linked another table where each row represents a rewrite rule. So for instance, here you can see that to make a type change from int to atomic integer, you'll have to perform the rewrite rule, which converts an assignment expression to a setter, like over here, or converts the object, the method invocation, instance method invocation to a static method invocation like this, when you want to perform a type change from file to path. Against each rewrite rule, we also collect how many projects performed it, how many commits performed it, and all the real world example links. Um, Type changes, the rules of the type change rules that we inferred. by TC Infer can be used to basically configure IntelliTC. IntelliTC is a IntelliJ plugin that performs type changes. Uh, it operates in three modes. The classic mode, where the developer invokes the refactoring manually from the context menu. The reactive mode, to overcome the discoverability problem of refactoring tools. We basically track the developer activity and we look for clues to see whether the developer intends to apply a type change, and then we recommend it to the developer. And the inspection mode, where the tool dev basically recommends type changes to eliminate misuse. For instance, here it is suggesting that we should convert function integer boolean to an int predicate to avoid autoboxing. Uh, in summary, TC Infer basically mines the version histories of the projects and infers type change rules, rewrite rules required to perform type changes. IntelliTC is a plugin, uh, an IntelliJ plugin to perform type changes which are inferred by TC Infer, and our tool and plugin can be found at this website. Thank you.
Awesome. Okay. So thank you, Amaya, for this presentation. And now we have ample time for discussion. So I would open the podium to all the to the presenters to be here, also to the audience to ask questions. Questions?
Hi.
Hi.
We have a question over here. It's for the first presenter. So I have actually two questions for the first and the second presenter. So I'm going to start with the first, and then I'm going to let other people ask. We're going to go further. So while the presenter said that refactoring are less challenging when it comes to shortening methods or refactoring code, and they are more challenging when it comes to IDE questions. I want to further develop on that and ask, are these IDE questions related to how to use the IDE, or what IDEs to use for something, or what are these questions?
Good question. So the questions around IDE and their difficulty was basically users or developers trying to do refactorings that aren't the simple, very complicated refactorings, not the simple rename or change type or things like that. They want to do like composite refactorings that aren't typically standard or built into the IDE. So those were the questions that weren't getting any answers because no one knew how to answer those questions. So that's basically what. And another reason, another instance was developers trying to do automatic synchronization of refactoring changes. So they make a change to the production code and they want that to synchronize to the unit test methods, and that wasn't happening. So those stuff that's not pretty straightforward, not built in by default into the IDE. Those are the questions that were challenging.
Thank you.
Sure.
So just to be clear, by challenging you meant questions that were not being answered, right?
Yeah, questions that weren't receiving an answer.
Okay.
So when you say a refactoring, you just mean a large code edit, not like something which is always behavior preserving.
Yeah, it's basically something, usually a large code edit or something that involves. It's very customized to that project. It's not like, hey, how do I do a rename using IntelliJ? Not stuff like that.
Mm-hmm. And were they describing? So I'm wondering if the lack of responses has to do with the fact that there is no support in the IDE, or there was not enough context, or maybe the context was so rich. If someone said, how do I migrate from this framework to that other framework, it requires so much more context, which they couldn't. And it's more like, going back to the James presentation on this, like, large architectural refactorings. Like, have you noticed whether some of the questions had some certain patterns about this being, very, very complex refactories that require a lot more context and people didn't have the context? Or
So in the subset that we reviewed, so we reviewed a manual statistically significant sample, and in that subset, it was mostly to do with very project specific questions, which and which we were and another issue was it was also to do with a lot of legacy code. Another reason that what we found out, we did a bigram, like I said, we did a bigram analysis, and we found one of the key bigrams was legacy code. So there are a lot of questions around legacy code as well, on how to refactor legacy code. I guess all of this combined, it makes it kind of hard for someone outside to come in and say, hey, this is what you need to do.
Mhm.
Interesting. Yeah. Thank you,
Yeah.
Anthony. It makes sense. Yeah, and this correlates kind of with what James was presenting earlier. So perhaps if you want to ask the question to the second speaker.
Yeah, the second speakers mentioned that he had a lot of answers from the industry partners, and it seemed really interesting. So I was wondering if he can mention some industry partners from those, or if it's private, or if it's not something to be said. We understand.
If you need to shoot us before you tell us the industry partners, then don't tell us.
No, we nothing like that, of course. But no, we can't really share the identities. We anonymized all the responses, unfortunately.
Okay.
But
We did, perhaps to give you a little bit of context, helps just a little bit. One of the questions we did ask was the size of the code bases they were working on in the first place. And if I remember correctly, better than 60, 70% were working on code that was at least 100,000 lines of code, and 1 million to 10 million was not uncommon in responses either. I gathered demographically there were a mix of IT systems, embedded systems, and probably a little bit of everything under the sun.
No, but it's impressive also the number of the responses. So it's really interesting. Thank you.
So a quick question to James. So in one of the slides you showed that IDEs are quite popular, right? In the bar chart. So do you know exactly what IDEs are popular? Like, is it Visual Studio, IntelliJ? What do developers frequently use?
Those were both very common responses. In some cases, the response was just, I use an IDE, not a specific product. If I remember correctly, Eclipse was also pretty large in the sample set.
Okay, so I think that ties with my stuff as well, because again, when we were doing the bigram analysis, the two famous IDEs were Visual Studio and Eclipse.
Actually, I have a question maybe for you, Anthony, on the legacy and the occurrence of that, because that we didn't look for bigrams. We don't have that systematic a study for such a small population, but it was a theme that seemed apparent from many of the responses. One of the biggest challenges that was identified was really trying to understand what the code did before they started refactoring. So this notion of comprehension, what does it do? What does this mess? Oftentimes seeming that it was something that was inherited from a decade past or something, was a pretty common question. And some of the more, I think, thoughtful requests for things that would help seemed to drift into ways to combine different forms of static and dynamic analysis to construct a better picture of how the code works and what it would mean to touch something here and what it impacts something over there in the code. And did you see any of that kind of broader requests maybe coming through?
No, so I didn't see anything around, what does this code do? It's more like, someone saying, okay, I inherited this system. There is a lack of unit testing in this legacy code. How do what are the steps that I need to take to start, implementing unit tests and things like that? I didn't see a question like, hey, what does this do? What does this? I didn't see stuff like that.
Okay, so
testing was also one of our most common responses, in that the lack of testing was something that cost a lot of time to try and correct. So
and again, that also neatly ties with my stuff as well, where we saw unit testing as one of the key topics, and we did a topic modeling exercise, and unit testing was one of the key topics that developers are requiring help with.
So Anthony, when you mentioned unit tests, are you mentioning the refactoring of the unit test files, or you meant unit tests supporting refactoring in general?
It's a mix. One is, okay, developers are saying, hey, you know what, I refactored the production code. How do I carry that into my unit test? Second one was, like I just mentioned, I inherited this code base. What are the steps I need to go about, in introducing tests and things like that?
Yeah, when
And
refactoring.
like I said, one of the key pain points was like this whole synchronization. I changed code in my source code. How can I push it to, like, say, the database schema or the unit test? They were looking for some way to automate that mechanism.
Okay, perhaps let me with this discussion, let me follow up with Amaya to include him in this discussion and say, can we use? I have a few questions for you, Amaya, but let me start with this one since this is the discussion. Can we use your tool to comprehend legacy code and learn the previous patterns of type migrations? And so I know exactly this is not what your tool is supposed to do, but can you see it support program comprehension from that aspect?
Like you can detect patterns from the previous edits. Like basically, the tool right now can give, if you give a small edit, like just statement level edits, it can basically figure out what is like the rewrite rule to go from source statement to the destination statement. So, if have you guys used the combi tool? I think the combi is like a it's it's a very popular tool these days for rewrite rules. So basically, it infers a combi template for edit. So even if it is legacy and you have made any change, if you give me the edit, it can figure out what is the rewrite rule required to perform that edit.
Yeah, so I know that the you had in your refactoring tool you have a couple of modules, like one to infer and one to execute properly what you have inferred,
Mhm,
right? But have you looked
mhm.
purely in the what you have inferred and see whether you have conflicts, whether you have things that are maybe, because I think if you look at things over time, you may have code that has been refactored in this way, on that way, by different people,
Mhm.
different domains, different times, right? And you may find even conflicts in
Yeah.
types, like, right? So maybe
Yes, yes.
this is
There are conflicts there.
Mhm.
Yeah. There are like some people. So in general, casting is not considered safe in Java. So if you're doing like casting from long to int is not safe. Rather, Java gives you a math dot the sum into long casting method. So now there are like, so some people to go from int to long, they're doing the casts. Some people are doing it more safely by using the utility method provided by the math package. So yeah, there is like this variation of how people do it. So some people, especially when they're adopting this new Java 8 API, they get like very functional and using maps and things like that. But on the other side, you can just see people not doing that and like actually having for loops there. So there is like a conflict in between how people go between two types. Uh, but currently, to resolve that conflict, basically we just rank it based on
popularity.
the number of unique projects where it is performed. So it
Yeah,
gives us like more context.
yeah,
Uh,
yeah. Makes sense. That makes sense. Interesting. So maybe, James, have you seen something like that in your survey where you notice that people may spend a lot of time resolving conflicts in types? Is that maybe one thing that makes up for the complexity of the refactoring?
That didn't emerge as a specific example from the data. There were lots of questions dealing with interactions among different pieces of code, even occasionally different languages, databases. But we tended not to get many responses at the line of code or individual type level. And I suspect that's kind of a bias when you're thinking about months or years of effort. Is that the detail that's going to stand out? And I'm not saying they didn't hit it. I'm sure that they did, but it wasn't obvious in the data, I guess.
So, James, can you give some examples of? I wonder if in this large refactoring effort, they've done like migration. So we are migrating the whole code base from using this framework to using this other framework, or we are migrating from, going from, I don't know, Java to Kotlin or some, what are some of the examples that they gave you that?
They did not provide specific examples in the introduction. We suggested these are the kinds of things that we think you're probably talking about, and it would be things like breaking up a monolith into smaller pieces so that you can go cloud native, for example. But anecdotal experience that we've seen in the past are things like removing dependencies on proprietary frameworks like specific database technologies to go to a more abstraction layer. And those tend to be the kinds of things that do have, again, in my experience, some pretty pervasive ripple effects throughout the code, affecting lots of locations.
It seems like, coming back to the first paper also, Anthony mentioned databases as one of the emerging topics that developers discuss a lot on Stack Overflow when it comes to refactoring. And this maybe brings the question of how exactly databases are being discussed in refactoring. Are we discussing refactoring databases themselves or the APIs of database inside systems? So what exactly is triggering the questions of developers when it comes to refactoring and databases?
So it's basically a mixed bag, right? So you have developers who want to, for example, modify the schema, right? A simple case can be renaming tables, table names, right? So that's one. They want to figure out how to do that and again propagate that change. That's one. Another really common pain point is readability of SQL scripts, right? Readability and reusability of SQL scripts. So they are posting, I had this huge SQL script. How do I compress it? Cut it down in size. And the next was again, the data access layer, right? How can I refactor the data access layer and so on. So though it was kind of a mixed bag, but it was all very database oriented. That's what we saw.
So they're
And
purely database oriented, yeah.
Yeah, it had to do with databases, yeah.
Okay.
And another emerging area that we noticed was the rise in questions on dynamically typed languages like JavaScript and Python, right? Because we looked at the tags, we analyzed the tags developers use when writing refactoring posts, and we saw that there is a rise of quite recently of JavaScript and Python. So that shows that, hey, developers are, having problems with refactoring these types of, code programs written with this type of code. So the question remains, in school, in universities, we are being taught refactoring using Java and C# using the standard techniques. Can those be easily done using in JavaScript, or do we need to come up with newer techniques to refactor JavaScript code? So that's one area that needs to be looked into.
That's my question to Ameya. Ameya, what do you do for your tool to support that? Can you support that?
I think the inference part will still work because it's language agnostic at some sense.
Yeah.
Because for two given ASTs, it figures out a rewrite rule. The application part, I think its accuracy will obviously be hampered because it's Python and you don't have the most accurate information until you actually run the code. But I think in most of the cases, just using these type inference libraries to like look up use references and users, I think that could work. So actually, I've been these days looking into these stack graphs, which are basically which now GitHub uses to resolve dependencies in resolve navigations in uh, Python code. So maybe something like that also could be used uh, to improve the accuracy of applying the type change.
Okay. So if I correctly recall, your plugin works on IntelliJ, right?
Hmm.
The second part. So you are using the
Yes.
the IntelliJ proprietary abstract syntax tree, the PSI, right?
Yeah. 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 I'm using
So
that. Yes.
okay. All right. Yeah, that makes it language
But
specific.
things are like at a very template level. So even inside IntelliJ, I don't actually I use its PSI, but what I actually use is the IntelliJ structure and replace templates, and I do everything just using those structure and replace templates. I don't
Okay.
actually deal with the PSI so much.
Okay. Okay. Good to know. Okay.
For Anthony, a question about Python. I'm curious, when people ask questions about Python, what are the kind of questions? Are they saying, how do I know how to do this in Java or in C# and I don't know how to do it in Python? Or is it strictly, here is some tricky corner cases of of functional features that Python has and Java doesn't have and C Sharp doesn't have. So I'm just curious about what's the nature of questions when they ask about Python. So that's the first question. The second one is it's let you answer this one and I'm asking you one on.
To be honest with you, I really can't remember what exactly they were asking in Python. I mean, I need to go back into the paper or dig into the data set. I'm drawing a blank as to what exactly they were asking for Python, the type of question they were asking. Sorry.
More like what are the kinds? Are they saying I already know how to do this? Can someone I already know how to do this in Java.
Okay.
Can someone explain to me how do I go through these mechanics when I do it in Python?
No, not to that extent. It was mostly to do with kind of reducing code reusability and readability, like reducing lines of code in methods and things like that. Those were the common pain points that we saw across the board: reusability and readability.
It's interesting how these two emerge for refactoring, right? Comprehension, readability, usability is interesting to see them emerging. Yeah, interesting.
And my second question for Anthony was on a framework specific. Are you seeing also of course, like everyone knows, the popularity of Python machine learning framework, TensorFlow and PyTorch and so forth? Are people asking questions that are specific to
Yes.
elements of how do I and what are the kind of questions when I ask about specific machine learning frameworks and
Machine learning frameworks, I'm not too sure, but I looked at the JavaScript frameworks. There were a lot of questions on when they were using JavaScript frameworks like Angular, React, and so on. And again, most of those, to be honest, Danny, were to do with, they weren't really specific about refactoring those types of technology. It was that basically they were using that API in building something, right? And they was, okay, I'm using this. How do I refactor the code? How do I design it in in a better way? Right? They weren't really trying to refactor, say, Angular or React. They were just using those APIs or frameworks in their systems.
Interesting. But I think we will, with the popularity of Python, as a community, we should be ready for a lot of questions about how to refactor Python code, which, to my understanding, it's still not a very hot topic in research. So I think as a community, we should get ready for that, because I guess if you look at the popularity of Python in Stack Overflow, is going really crazy. So, and yeah, we'll have a lot of data sciencey type of questions coming soon to us, to how do I refactor this knowledge, this code. So yeah, we'll be ready. We should be ready for that. It's gonna be coming soon. Yeah, we have one question from Ting Ting in the chat. So she's saying, this question is for James. She said, I was wondering if architectural knowledge plays a key role in refactoring in industry. Like, what design decisions or what specific quality attributes do you document that knowledge?
So I think the closest we got to that in the survey is we asked some motivation questions. So we divided the category. What were your business reasons for wanting to do large scale refactoring? What were your technical reasons? And architecture crept through a little bit in that space. When we're talking about business reasons, more than half the respondents replied with a lot of things you would expect: reducing time to deliver features, feature reuse across systems. Maybe one that was a little bit surprising to be that high was to reduce reliance on unsupported or outdated technology. That ranked fairly high. And that was on the business side of things. And the technical side, migrating to a new, the second most common response. We didn't get to the level of specific quality attributes. We focused more on these development considerations, of which the development velocity is probably the closest to that, and that did rate quite high.
I have like a follow-up question here. So these industry participants that you surveyed, the refactorings that they did, was it like a centrally driven refactoring for like the entire code base, or was it like a more of a program that they were a part of and all the teams in that company had to do a certain kind of refactoring? So I'm curious to know like what was like the mode that they used, and because I don't have a lot of experience, but in my last 6-7 months of experience of doing refactoring in industry, I realized that doing it centrally is very difficult because If your tool throws an error, you don't know what is the context of that code, or you're not like the best judge.
So I think all of our questions were oriented towards tell us about an experience on a specific project. So that's what we really extracted. I am familiar from other examples. For example, security initiatives tend to be something that is deployed more widely than just a given project. Another thing that we have seen not enough of, I would probably argue, is taking a portfolio perspective on refactoring, right? So given federal agency or industry organization has dozens and dozens of systems, and it's not all that uncommon for multiple systems to have implemented the same functionality, like an authentication service, and maybe you've got 10 of them across your organization and they're inconsistent. There are opportunities at the portfolio level to think about refactoring as a way to commonalize a shared service that can then replace the need to maintain 5, 10, however many variants of essentially the same service. And those things do tend to take buy-in from different project teams in order to be successful. And I am aware of some politics that makes that difficult, because who's going to pay for this refactoring? It's not my pod, it's not your pod. How do we share that cost? And how do we migrate? And maybe we like our version, and that those non-technical factors do come into play. I guess, and this is well outside the survey. I'm just brainstorming, I suppose.
True.
But in such cases, I would hope that there are good cases to be made in understanding the cost that organizations are incurring by supporting n variants of a common thing. This gets very much into the technical debt thinking that EPEC has led for years. And there are hopefully data-driven approaches to gather that data, make it more visible, and help persuade organizations to do this.
Indeed, actually, we are, as a community, we are in need of, as you explained, need of case studies, industrial case studies of how they estimated the cost of refactoring and how they applied it. And I was there in Cleveland, 2019, where there was actually a paper about that. It was a paper by Stéphane Ducasse, I think, where they were discussing how, I think it was Siemens, the company, how they spent a lot of time, weeks, refactoring what they called God classes, right? And obviously we know God class. So it's that black box that nobody dares to touch in the code, right? And it was one of the few papers that I've seen that were explicit about it, and like how developers they were discussing it, how they were discussing how they would break down the God class, what are the methods that needs to be moving in, and how they did that by coloring all dependencies inside the God class as if it's a cluster, and then they look at the high clusters inside the God class and they start breaking it down slowly into layers. And I think they talk about the cost of doing that, because there were a lot of architects, software architects involved, and that was very costly. And I remember, if I'm not wrong, they mentioned they had 15 God classes in their system, and they spent almost a month just fixing one. And they were like, okay, that took a lot of our effort. They didn't expect this to be so complex. So they were looking for ways to optimize the refactoring of the remaining God classes, if not just giving up on them. Right. So I would maybe look for the paper and share it with you, because this answers perhaps or supports your answer, and also answers maybe think question about how developers discuss architectural decisions when it comes to refactoring large scale code. Yeah. Yeah, I'll search for it. Any other questions?
I also have a question for James. I was wondering if in your survey or research, if one of the topics that was very costly, like in terms of refactoring time, was security-wise. And the reason I'm asking is that, for example, in the previous company I worked with, we spent quite a considerable amount of time to, for example, at one point we wanted to be PCI DSS compliant and to have this. So that kind of put us in a refactoring mode, not to store passwords and in databases it's clear, and in log files, etc., etc. So it was like, I was wondering if in your research this kind of topic emerged, or
not directly. There weren't a lot of comments that spoke directly to security concerns. Some of the things that we asked about, we took just a starting slice at the different activities that might be involved in large scale refactoring to structure responses. And the closest category we had to that involved certification of code. There's some safety domains, medical devices, avionics, where there's some certifying authority that has to approve code that has been refactored because of its role in a product. And that is about 10% of the respondents actually commented on that as a significant issue for them. It wasn't dominant. But in the open responses, there really wasn't much directly on security.
Right.
Okay, let me perhaps ask Amaya one question about, since Amaya have implemented the plugin for refactoring. So I was wondering about how do you evaluate the usability of your tool? Because I guess one of the main perhaps challenges that I have seen over the years about refactoring research is the adoption of our tools, right? So how do you make sure that your tool is intuitive for the developers?
So first, we have a standalone tool demo paper. So let me just publicize that uh, for Intel ETC. So we actually solved it very technically. We came up with these three modes. The first mode where a developer has to actually invoke the plugin. The second mode, which is spying on the developer and figures out, oh, the developer is about to perform a type change. Maybe I can recommend it to him or her. And the third one is basically it tells you that, hey, I think you should perform this type change. So that is how I have technically taken care of the usability. Uh, because I collaborated with these JetBrains folks, so we've also managed to create like the what do you call it? The data collection layer, which
Mhm.
basically is collecting all the events that are done in the GitHub, sorry, in the IntelliJ IDE while using our plugin. Yeah. So,
Okay, so I have a
and we've
question for
done
you.
like a survey
Okay.
with
Let
11, with 17 developers, and we did not tell them to use our tool, but we showed them how this tool could be used, and we asked them whether it would be useful. Because asking someone to use our tool, I tried a lot of I tried a lot around doing something like that, but it was very difficult. How do I convince someone to first install my tool, and then in his or her day-to-day job, they should be at this point when they'll use my tool, and then they'll give me a good review. And this will all happen before a deadline for which I have to submit. So doing that is actually not possible. Like we spent multiple months thinking about, creating this infrastructure to collect information, but we said we support like 80 type changes, but having a developer actually perform them naturally in their code base is very difficult. So I don't know how to actually see how the tool is doing in the wild, at least like a research tool, unless it gets accepted by IntelliJ and they're distributing it and it's in the hands of many people.
Yes, yes. I think this is a good point, is validating our tools. Maybe in your case, it's a bit tricky to find clear scenarios of, I mean, I think there are a lot of type migration that developers do on a daily basis, but maybe for you to be able to enforce your tool as an evaluation, that's a good question. Yeah. So how do we do that, and how do we allow people to trust the tool when it's still in a beta evaluation? So, but maybe I know that you have not done this, but in your reactive mode, you are kind of spying on the developer, which is not a bad idea to kind of promote your refactoring as the problem is
Mhm.
happening, right? So, but wouldn't you be worried about annoying a developer with a lot of maybe kind of notifications about, yeah, you need to do this way, auto completion? Wouldn't you be try to
So
be
we've put
maybe?
a
Mhm.
timing heuristic, like it's
Oh,
something
okay,
25, 30
okay.
milliseconds or something like that. And if the developer doesn't accept it, the uh, notification goes away.
So you
Yeah.
thought about all these scenarios. Okay, this is good. Okay,
Yeah,
this is
yeah.
good. Okay,
We
yeah,
thought about, so that paper lists all of these things that we built into that plugin.
yeah,
Uh,
yeah. That's good. That's very good. That's answered my question. Thank you, Amaya. Hmm.
And Amaya, going back to I think Mohammed, you were saying earlier about how can we get access to proprietary code bases and how can we study case studies in industry, and if people like James want to look at at the large architectural refactoring that happened at Uber. So now that you've been both in academia and you finished your PhD last year, and now you're at Uber and working with one of the larger code bases out there in industry, what advice do you have for people of how can they approach companies in order to do a case study at the company or in order to do to replicate something we are doing from open source and proprietary code bases? Like, I would imagine that lots of the people who are listening to us and have their video and camera turned off are students who are saying, I need to get some collaborators in industry. What advice would you give them? Because you've been a PhD student not too long ago, and now you are in industry, so you see the both sides of the coin, I guess.
Yeah. So I think my experience in industry is just like 6 months. So yeah. So take it with a pinch of salt. But I think that at least if someone approaches me and says that, oh, I want to do this cool thing and I want, you to test it on your Uber code base, I'm actually ready to do it. But I think documentation for that tool is very important. Like it should kind of work out of the box. Like, or else it is very difficult for me as a person to, because even I have my own research agenda. Now, if I want to collaborate with someone, it's like a part of my time that I'm going to give it to it. So I kind of not expect, but like things should be well documented and I should be able to run those things easily, or not easily, but at least it should be doable, maybe in an afternoon's work. But it should not be like or something which taken me 6 7 days to just like tinker around and configure and make it work. I think if we produce more reproducible, like easy to use tools, it's much easier to run it in the industry code base then.
Yeah, totally agree with you. Yeah. Yeah, maybe let me ask you this nasty question. So why haven't you tried your own tool in your own code base since you're also
I've
developing?
tried my own tool in my own code base. Yeah,
Okay.
yeah, yeah.
I knew it was working, right?
But yeah, it's working. Yeah, but I can't discuss what I found.
Okay, but that's
What is
Yeah,
that's
it works. Yeah, yeah, yeah.
the
Yeah. I
overview?
run a lot of researchy tools on our code base. So if anyone has any cool idea that we can that can be useful for us also
yeah.
too, but yeah, please feel free to reach me.
Yeah, yeah, actually, Danny brought a good idea, a good topic for all the prospective PhD students who want to develop refactoring tools. Are yeah, to reach out to researchers and ask them about maybe all the experiences and maybe the bad experiences of, of building refactoring tools, so that you do not do the same mistakes, right, Danny? So, can you tell us more, Danny, about that? For example, like some of your experiences with building tools for refactoring and how you know things you learned over the years about it.
Yeah, yeah. So I guess probably one of the biggest lessons that we learned was if you want to have like an industrial partner, it's many people think about it as an afterthought. Like I'm doing some research and oh, it'd be cool if Uber or Google uses it. But in the example that Amaya mentioned from XC 2019, when we had refactoring for the largest Java code base in the world at Google with hundreds of millions of lines of code, it was from the beginning. It was like we started working with Google and we look at the problem and how what are their challenges and what are their needs and how do we need to solve their challenges and their needs. And so it provided a lot of inspiration for our tool. It was not like, oh, we do something and now let's see if it's like I have a hammer, like let's look for a nail and see if I can hit. But no, it was more from the beginning. This is the nail that was present at Google, and how can we design a solution that fits them like a custom glove, that. So that's why they were adopting it, and they were keen to apply it internally. So I think that was like one of the biggest lessons that we learned. We developed lots of tools, and many of them are shipping with official list of Microsoft Visual Studio and Eclipse and IntelliJ, um, and that was it. Like whenever we were fortunate to do that, it was because we start working with partners in the industry of the company from the beginning, from the inception. It was not just at the end. Oh, let's try to ship it to them and see if they take it and what they think. No, it was like they were part of the whole design process, and had lots of like discussions, like weekly discussions for think about like several months, a year long or so. Um,
Yeah, thank
so
you.
I
That,
think,
yeah, if I had to summarize what you said, we should not start with the solution, then look for a problem. Instead, we should go to the problem, spend a lot of time understanding it, take the hard way, but
yeah,
that would be in the end a better and more efficient solution. Yeah, yeah.
right.
Thank
My
you.
2 cents to it, but I realize why the thing works with the industry. From if you work with them from the beginning, is because you use the infrastructure to make your research whatever that company is using, so it just becomes easier to port your research into